doing concurrent coplanar forces, in which I have already told you what it is. Just a quick recap. You can see from the slide that coplanar concurrent forces are those forces which originate or their line of action meets at a common point. Since we are studying coplanar, so all these forces have to be on the same plane. Got it? Now, here in mechanics, what we are interested? We are interested in finding the effect of the forces on the body. On a body, if single force is acting, we can always say what it will do. Maybe it will move the body in a particular direction, it may rotate the body, whatever it is. But if more than one force is acting on a body, then it will be difficult how the body will behave. I hope you are getting it. Suppose I am pulling a car and you are pushing the car. So that means car will move in the direction in which I am pulling because you are supporting me. But similarly, if you are also pulling the car from the back and I am pulling the car from the front, now what will happen? We are opposite. So we don't know what will happen to car. If I am stronger than you, I'll pull the car. If you are stronger than me, you will pull the car in your direction. Got it? So similarly, it is not always necessary that the forces will act opposite or to each other. It may be in the same line, it may be at certain angle. Maybe you are pulling the car from the side and I am pulling the car from the front. Then what will happen to the car? So such type of effects we want to find out in the mechanics, for which we will have to find out a way and means that to replace these two forces into a single force which will produce the same effect on the body. Got? I hope you are getting it. Okay. So now let us proceed. So to find out the single force, this single force which replaces all the forces acting on the body is called as the resultant. Okay. And this resultant will be not equal to any force, but it may be a different force whose magnitude, direction may be different. So we will have to find out both. Since we are studying concurrent forces, that means the point of application of the resultant and the original forces will be the same. There will be no difference. Okay. So this resultant will produce the same effect on the body as the original two or more forces were producing on the body. Okay. There are various methods to find out the resultant. One of them is law of parallelogram of forces. This gives us both. Law of parallelogram of forces gives us both the analytical way to find out the resultant and the graphical way to find out the resultant. It gives us the both. So now what is law of parallelogram? Law of parallelogram states that on a body, if two forces are acting, we are talking about only two forces, not more. We will come to it later. So these two forces, since they are concurrent and coplanar, so they are in same plane and acting at the same point. If we take these two forces as two sides of a parallelogram, the diagonal of the parallelogram will give us the resultant. The length of the diagonal of the parallelogram will give its magnitude. The angle which it makes with either one of the forces will give us the direction. However, as I have repeatedly told you, the point of application will be the same. Okay. Now, how do we draw this parallelogram? So, let us take an example. Let two forces P and Q are acting at a point O. In the figure I have shown here, O, at an angle of alpha to each other. Okay. So now, first of all, we choose a scale. Means, say the force is of magnitude 10 newtons, and we choose a scale that 1 newton is equal to 1 centimeter. Then the length of the line will be 10 centimeters long. So this is the scale. You can choose any scale. Maybe 1 newton is equal to 1 millimeter, or 1 newton is equal to 5 centimeters. You can choose any scale. Depends upon the availability of the space, paper size, and the length of the scale and all that. You can consider any suitable scale. So first, let us draw a line OA. We draw a line OA. The length will be equal to the magnitude of the force. Say, along the line OA, force Q is acting. Okay. So, OA will represent my Q in magnitude. Okay. Similarly, P is acting at an angle of alpha. So we draw another line OB, making an angle of alpha with OA. Got it? The length of the OB will be on the same scale. Remember, for both the forces, scale will be same. The length of the OB will be equal to force P on the chosen suitable scale. Now we complete the parallelogram. I hope you know how to complete. Okay. And then we draw this diagonal OC. This diagonal, if we measure it, it will give the length, will give you the magnitude. Length means, say I have taken 1 newton is equal to 1 centimeter, and the length OC is 12 centimeters. That means resultant is 12 newton. And if we measure the angle theta, which it makes with the force Q or the line OA, this will give you the direction in which this force will act. Means, if we apply a force R on the body, it will give you the same effect as the force P and Q together were giving. Okay. So this is the law of parallelogram, and how it is drawn I have told you. Now let us come to the proof. We will give you analytical proof. So what we do, after making this parallelogram, we drop a perpendicular from the point C here, point C on the line OA, since it will not meet because line is terminating at O, so we extend this line, and I have shown it with the dotted line. On the extended line, if we drop a perpendicular from C, this is CD, and the angle ODC or CDO is 90 degree. That means the triangle OCD is a right angle triangle. Got it? Okay. Now, in the right angle triangle, from properties of triangle, we know that OC square, that is hypotenuse square, is equal to sum of square of the perpendicular and square of the base. Okay. So we will be using this property later. Now before that, one more thing. From properties of triangle also we know that angle BOA, that is the angle between the two forces, original forces P and Q, which it was making. This angle will be same as angle CAD. From properties of triangle, you know, I need not go into the detail of this properties of triangle. Anyway, so I think you know, that means this angle BOA will be equal to CAD. Both angles are equal. Okay, and OB will be equal to AC. OB will be equal to AC. That means OB, which is representing the force P. Similarly, AC will also represent the force P. Got it? Now, coming back to the properties of triangle, we say hypotenuse OC square will be equal to OD square plus CD square. Now, OD we don't know because force Q is represented by the line OA. So what we do, we try to find out AD. AD is what? AD is CA cos. Okay, that means AC cos of this alpha will give me the AD, and similarly CD will be AC sine of alpha. Okay, this is all from properties of triangle. So if we substitute the value, OD is OA plus AD square and CD is same. CD is nothing but the force P. Okay, and OA is nothing but force Q. AD is, as I have just explained, AD is AC cos of alpha, or alternatively we can say it is P cos of alpha. So here I have substituted the value. This is Q square, and when we expand this bracket, it will give me P square cos square alpha plus 2PQ cos alpha plus P square sin square alpha. Okay, now from this P square factors I bracket them. So this becomes Q square plus P square in within brackets cos square alpha plus sin square alpha plus 2PQ cos alpha. Okay, and since cos square alpha plus sin square alpha is 1, so this will reduce to Q square plus P square plus 2PQ cos alpha. Got it? Alternatively, we can say R is under root Q square plus P square plus 2PQ cos alpha. Okay, this is the analytical way, and we have to find out the angle. Let us say this hypotenuse or the line OC makes an angle theta with OA or OD, that is force Q. So this resultant is making an angle of theta with the force Q. So here also, if we take tan of theta is nothing but CD upon OD. Okay, CD upon OD, and OD is again OA plus AD. OA plus AD. So CD is P sin alpha, and upon Q plus P cos of alpha, because AD is P cos of alpha, as I have said again. From these two we can find out the magnitude and the direction of the resultant. Okay, now we move further. This we can extend to more number of forces also. For example, as I have said, let us say we have three forces, P1, P2 and P3 acting at a point O. So let us first take P1 and P2 and we draw a parallelogram OADB. OADB as I have explained earlier, and we find out the resultant R1. Okay, that means for force P2 and P1 we can replace them both of the forces with R1. Now we take R1 as one force and P3 as the second force and complete the parallelogram. Okay, so we will again get a second resultant or the second diagonal, which we call it as R2. So this R2 will give us equal and the same effect on the body as P1, P2 and P3 together were producing. Okay, I have drawn here in the dotted line the second parallelogram, that is with the resultant of the first two and the third original force. Okay, so this way we can extend it to a number of forces. This can be extended not only to the coplanar, but it can be extended to three-dimensional also, this concept. Okay, now we move a little further. We take up some special cases. We know that, let us take the special cases for two forces only. Now if the angle between the two forces is 90 degree and we know R square is equal to P square plus Q square plus 2PQ cos theta or alpha. Since angle is 90, so cos 90 is 0. So that means the term 2PQ will become 0. So my problem will reduce to R is equal to under root P square plus Q square. Got it? Similarly, if the angle between the two forces is 0, that means they are acting along the same line. In that case, this will reduce to resultant is equal to P plus Q, as cos 0 is 1. Okay, that means they will be acting on the same line, and of course the direction will be the same in which both the forces are acting. If the angle is 180 degree, that means they are acting opposite to each other. The resultant will be again be R is equal to P minus Q, as cos 180 is minus 1. Okay, and the direction will be in the direction of the greater force. Just the example which I took in the beginning, say I am pulling the car from the front and you are pulling the car from the back. In that case, if I am stronger than you, the car will move in my direction, and here the forces are acting at 180 degree, means we are opposite to each other. Okay, and of course, just a reminder once again, point of application will be same because it is all concurrent forces. Okay, we will take up other methods of the finding resultant in the next class.